Alright, hey guys, this is going to be the 6.6 summary video, and we'll be discussing the topic of derivatives of inverse trigonometric functions. Just a quick little overview. I'll be talking about the formulas for the derivative of inverse functions, inverse trig functions, and also as well as the integration formulas, and a little bit on the generalizing formulas as well. Okay, starting off with the formulas for the derivatives. As you guys can see right here, starting off with the derivative inverse sine, that is equal to 1 over the square root of 1 minus x squared. Derivative of cosine inverse is negative 1 over square root of 1 minus x squared. As you can see, it's the same as the one for sine, but just with a negative in front of it. Then we have the derivative of tangent inverse, which is 1 over 1 plus x squared. Derivative of cosecant inverse is negative 1 over x times the square root of x squared minus 1. The derivative of secant inverse is 1 over x times the square root of x squared minus 1. As you can see, the cosecant one has a negative in front of it, as opposed to the secant inverse. And lastly, we have the derivative of the inverse cotangent, which is negative 1 over 1 plus x squared. It's just, you just place a negative in front of the tangent inverse. So it would be good to memorize this or put these on your cheat sheet, I would feel like. I think these three right here, this inverse sine, cosine, tangent, are probably the more common ones that you should probably just memorize and just kind of remember, like, they're the cosecant, secant, and cotangent, like their counterparts, and where to put like the negatives or whatever. Now moving on to the examples. Start off with this first one. We have cosine inverse of 7x minus 9. If we want to find the derivative of that, d over dx cosine inverse 7x minus 9. We go back, if you want to find the cosine inverse, we look back at the formula up here, which is negative 1 over the square root of 1 minus x squared. Remember that. And for this case, instead of just x, we have 7x minus 9 right here. So the way I think of it is just like, this is basically just x. You could put like u or something else like that, but I just like to think of it as just the inner function. So I think after that, you get this bit right here, negative 1 over the square root of 1 minus the inner function, which was 7x minus 9 squared. And because there is an inner function here, we do have to apply the chain rule. So you multiply it by the derivative of the inner function, which is d over dx of 7x minus 9. And the derivative of this, right, 7x minus 9 is just 7. And you multiply that by the formula, by this formula right here, this part right here, and you get negative 7 over the square root of 1 minus 7x minus 9 squared. You could kind of simplify this out more, but I think it's okay to just leave it as is. Now moving on to the second example, we have the inverse tangent of the square root of x. If you want to find the derivative of this, we go back to the formula right here. The derivative of tangent inverse is 1 over 1 plus x squared. And like in this example earlier, this inner function, the square root of x, is basically the same x right here. You just kind of plug that in. Or you could like substitute it for like a u or something else. Okay, so put in the formula, 1 over 1 plus x squared, you plug in that is the square root of x squared. And since this is an inner function, we do have to apply the chain rule here again. Multiply it by the derivative of the inner function, which is the square root of x. And off to the side here, I just found the derivative of the square root of x. You could rewrite it as x to the 1/2, and the derivative of that. Exponent rule, you go put the 1/2 in the front, and you multiply it by, minus it by 1. You can rewrite that as 1 over 2x to the 1/2 power. That could also be changed to 1 over 2 square root of x. And that's what this part shows right here. Multiply the two together, you get this portion right here, 1 over 2 square root of x, parentheses 1 plus x. And then from there, you could multiply top and bottom by the square root of x. Top becomes square root of x, the square root of the two square roots of x multiplied together on the bottom equals x, just equals x. So you would get 2x, parentheses 1 plus x, so the final answer would be square root of x over 2x, parentheses 1 plus x. Now moving on to the inverse trig functions, or the integration of the inverse trig functions. As you can see here, you're just going backwards from the derivatives for the integrations. As you can see here, the integral of 1 over square root of 1 minus x, the x squared dx equals the inverse sine. This one, bringing it over from a different screenshot kind of messed up the formulas a little bit, so apologize. But for this one, it's the integral of 1 over 1 plus x squared dx equals the inverse tangent. And then here's the integral of 1 over x times the square root of x squared minus 1 dx, which is the inverse of secant. And there's only these three right here because you can just go from just integrating like this and finding the inverse of cosine, but it would be like much easier to just bring that negative out, finding this. Oops. We know that this one is sine up here, so at the end that would just be sine inverse of x plus c. And that's like the same for the same for cosecant and cotangent as well. These three formulas down here are the generalizing formulas. So in the case of when we don't have this one right here, but you're able to like simplify the formula where you're able to have, where it's able to become like this form of the integral, then you could just go ahead and use these to figure out the antiderivative. And we'll go over an example of that in the next slide. So this first example, we have the integral of 5 over the square root of 1 minus x squared dx. If you look at the bottom here, we see the square root of 1 minus x squared, so we go back up here. That's pretty similar to what this is right here. We just need to get this 1 somehow. And this one's fairly simple. Since it is a 5 on top, we could just factor that out. That's what we did right here. And then we have 5 times the integral of 1 over square root 1 minus x squared dx. And we already know that this right here is from the formula above is the inverse sine of x plus c. So, and then from there you could just figure that one out. And then the answer we get is 5 inverse sine of x plus c. Don't forget to put the plus c because it is integral. Here we have the integral of 3 over 25 plus x squared dx. Same thing we did over here. You could factor out a 3. We have 3 over 1 over 25 plus x squared. If you look back at our formulas, it looks kind of similar to right here, except we just need to change the 1 to the 25 to a 1 here. But what we also notice is that if we look at this formula right here, 25 is a perfect square. So that's why when we look at this, well, that's why when we look at 25 and we see that's a perfect square, we want to look at this formula right here. So first you do a little bit of substitution, kind of manipulate the formula to get to this form. First we'll let u equal x, so x squared equals x squared. So I'll take care of this part. And then here we could let a squared equal 25 and a equal 5 because it is a perfect square. And then finding the derivative of u, du equals dx. So finding all of these values right here and plugging them into this form, plugging them in or substituting them out, you get the 3 times the integral of 1 over a squared, that's from right here, making our 25 equal a squared, plus u squared right here, making the x squared equal u squared, du. Now we look at this, we have 1 over a squared plus u squared, which is right here. Oh, I just realized that this square root should not be here. That's the screenshot problem. So just ignore this square root right here. So we see that the integral of 1 over a squared plus x squared is equal to 1 over a tangent inverse x over a dx plus c, which is exactly what we have right here. So we could substitute that in, and we get 3, 1 over a tangent inverse u over a plus c. Plug back in these values. There we get 3 times 1/5 tangent inverse x over 5 plus c. Bring it back over to 3. And our final answer that we get is 3/5 tangent inverse x over 5 plus c. Hopefully that was helpful for you guys, and hopefully, good luck on the test.